Dear students, good morning everyone. Now I am going to explain the derivation of discussion of the conformal transformation W equals to Z square. Here W equals to Z square is the mapping from Z plane to W plane. Here we have to find the images of straight line in Z plane to W plane. We have to prove that W equals to Z square is a conformal transformation by considering two straight lines, one straight line parallel to y axis, another straight line parallel to x axis. Their angle is 90 degree. So we have to find their images. We have to prove that their angle between their images also equals to 90 degree. The angle in z plane is same as angle in w plane. Then we have to conclude that this transformation is conformal. Consider a transformation w equals to z square. Put z equal to x plus iy, w equals to u plus iv. Substitute into transformation, we get like this. Here by expanding, we get x square minus y square plus 2i into 2xy. By comparing real and imaginary part, we get u equals to real part x square minus y square, v equals to imaginary part 2xy, call it as equation number 1. Now we have to find images of straight lines and circle of z plane in the w plane. Here we have the equation for u and v. U and v are the coordinates in w plane. We have the expressions. By considering straight line in z plane, that is case 1, consider straight line parallel to y axis. This is a straight line parallel to y axis. That is equation is x equal to c1. Substitute into equation 1. We get u equals to x equal to c1 substitute ಮಾಡಿದ್ರೆ we get c1 square minus y square, and similarly another equation v equals to 2xy. Substitute x equal to c1, it becomes 2c1y. By this equation we can find the value of y. By cross multiplying 2c1 to LHS, we get y equal to v by 2c1. Substitute this value here, it becomes u equals to c1 square minus y value square ಮಾಡಿದ್ರೆ v square by 4c1 square. Transfer this term to LHS, we get like this, and minus v square by 4c1 square can be written as minus can be written here, and cross multiply this term to LHS, we get v square equal to minus 4c1 square into this term u minus c1 square I written here. This equation represents parabola in the w plane with vertices c1 square comma 0. Here c1 square value we get here u minus a. It is in the form u minus a. A value is the c1 square here, and focus at the origin. This is the parabola in the w plane. So we can conclude that straight line, image of a straight line in the w plane is parabola. In case 2, consider a straight line parallel to x-axis. Its equation becomes y equal to some constant c2. Substitute into equation 1, we get u equals to x square minus c2 square, and v equals to 2c2x. That is, by substituting into equation 1, we get these two equations. By this equation, find the value of x by cross multiplying 2c2 to LHS. So x equal to v by 2c2. Substitute x value v by 2c2 here. So we get this equation, and transfer c2 square to LHS. U plus c2 square equals to v square by 4c2 square. Cross multiply this 4c2 square to LHS. We get v square equals to cross multiply 4c2 square into u plus c2 square. This equation also represents a parabola in the w plane, because this equation contains variables u and v. Therefore, it is a curve in w plane. So it is a parabola with, but here foci is u minus a, but here plus c2 square can be written as minus of minus c2. So vertex becomes minus c2 square comma 0. Look at the diagram. A straight line parallel to y-axis x equal to c2. Straight line parallel to x-axis y equal to c1. Their images are parabola with vertices c1 square comma 0 and parabola with vertices minus c2 square comma 0. So their angle also 90 degree. Therefore, this transformation is conformal. Similarly, in case 3, consider a circle with center at origin. Its equation is mod z equal to r, z equals to r into e power I theta. Substitute into transformation only for z, w equals to r into e power I theta whole square, r square into e power I 2 theta. So r square can be written as capital R, e power I 2 theta can be written as phi. So this equation represents circle in w plane, but here radius r equals to r square and angle phi equals to 2 times theta. Look at here. Suppose this is a circle with center at origin and radius r and subtending angle theta. Its image becomes again a circle but radius to square of the original radius r equal to r square and theta also 2 times phi equals to 2 times theta. Next, in case 4, consider a circle with center at A in z plane. Its equation becomes z minus a equal to r. We get z minus a equal to r into e power I theta. Transfer a to RHS. Z equal to a plus r into e power I theta. Substitute into transformation. W equal to z square. It becomes like this. And by using a plus b whole square formula, expansion. Next, transfer a square to LHS. W minus a square equals to remaining 2 terms as it is. Next, by adding r square on both sides, we get here also r square, here also r square, and this can be written like this. Here r square is common in both the terms, take it outside. So remaining term is 1 plus e power 2 I theta. Here divide and multiply by 2 into e power I theta. Multiply and divide. Here take here in both the terms 2 r e power I theta is common. Here also 2, 1 r and e power I theta can be taken outside. So remaining thing is a, and here r square, therefore 1 r is left, and in the denominator term as it is here into 1 plus e power 2 I theta as it is. Right. Next, e power I theta in the denominator. If it transfer to numerator, it becomes e power minus I theta, and multiply to inside the terms. It becomes e power minus I theta into 1 is e power minus I theta. E power minus I theta into e power 2 I theta. Plus 2 I theta minus I theta becomes I theta. Here, e power minus I theta plus e power I theta divided by 2 is cos theta. Right. Finally, we get this equation, and suppose w equals to w minus a square minus r square equals to r e power I phi. This is the equation of the circle in w plane with the center a square minus r square. Is the equation of the circle. Then by comparing these two equations, LHS are same. By comparing RHS terms, e power I phi, here also e power I theta. So theta equals to phi, or phi equals to theta, and in the place of r we have 2r into a plus r cos theta. This equation represents a lime cone in w plane. So look at the diagram. If we suppose we consider a circle with center at A in z plane, its image becomes a lime cone in w plane. So these are the 4 cases in the conformal transformation w equals to z square. Thank you.